Okay, so I'm going to take you through the rational zeros theorem, that first example from 2D one more time. If you already understand it, then you can skip this one, skip this video, and just go on to the next one. So the rational zeros theorem gives you candidates for zeros. And I almost think it's easier to just do an example than it is to try to explain all the details of this theorem, which we did in class. So if we look at this example, list all of the rational zeros, potential rational zeros, of this function according to the rational zeros theorem. Okay, so let's do that first, and then we'll do the rest of the problem. So potential rational zeros from a polynomial, they come from factors of this and factors of this, the factors of the constant term and the factors of the leading coefficient. So the factors of the constant term are the factors of -2, and then the factors of the leading coefficient are the factors of 3. So that's going to be on top 1 and 2, positive or negative, and on the bottom 1 or 3. So if I work these out, well, I've got plus or minus 1, I've got plus or minus 2, I've got plus or minus 1/3, and I've got plus or minus 2/3. So that's 8 options for rational zeros. Now later on we'll find out you can't have more zeros than this power, the biggest power. So I can't have all 8. And you basically have to test them until you find out which ones work to help you factor the function. What I'm going to do is we'll just test the number x equals +1 and see if that works, which I'm rigging it because it does work. So I'm going to put 3 here, 4 here, -5, -2. We'll use synthetic division. So if I bring down the first term and then multiply and then add and then multiply again. So 1 times 7 is 7, 2 here, multiply, get 2, and then add, get 0. So since the remainder is 0, which is the same thing as f of 1, that means that x minus 1 is a factor of f of x. So that tells us that we can write out f of x as x minus 1 times, and then this gives me the next term. So it's 3x squared plus 7x plus 2. And this one you can factor by hand. X minus 1 times 3x plus 1 times x plus 2 is what that turns into. So if we had happened to test instead -2 right here, over here instead of 1, then we would have gotten a remainder of 0 still. And the quadratic that we would have ended up with was whatever that multiplies out to. Or if you had happened to test -1/3, which is what you get out of this, when that's set equal to 0, -1/3 would also give us a remainder of 0. But any of the other 5 choices we have up here, you would have gotten a remainder and you would have had to test other things instead. Okay. So when you're ready to move on, after you understand this example, find the next video, and then I'll show you what I expect, so that because I don't actually expect you to test all 8 of these every time.